started. We are very late, so 1 minute. So today we will finish chapter 4 and start chapter 5, and also we will talk about the first exam. Talk about the exam. So we will have the first exam on 20th and 21st. So we will have the exam online. Okay? So you will have 2 days to work on that exam. So that exam will be 75 minutes. Each will cover chapters 1 to 5. Okay, so we are working on chapter 4 right now, and today we will start chapter 5. So for the exam, you have 75 minutes, and we will have 25 questions. So the questions will be similar to your homework questions. Okay? So my suggestion is please review your homework questions. Okay? Yes.
Will we have class next week?
We don't have class on Tuesday. Okay, we don't have class on Tuesday. So you can work on the exam anytime during those 2 days. But once you start, you have to finish it. Any question? Okay, chapter 1 to chapter 5. So any questions? Yes.
Are we going to be able to use stack function in Excel? Like, is it going to let us pull it up or is it going to let us?
Yes, can we use the stack function? Yes, the answer is yes. You can use the calculator, you can use Excel, anything you can get. But you only have 75 minutes. Okay? So my suggestion is, if you need to do some calculation, if you can do it in the stack function. So several questions we already demonstrated how to do it in the stack function. So please use the stack function, okay? Because that's the easiest way. It will save you time. Okay? So please use that. And another thing is, for some concepts, so in the previous chapters we talked about several concepts. So my suggestion is to have your textbook or PowerPoint slides ready. So you don't have to remember all those concepts, but in case in the exam you need to use some of the concepts, you can just borrow that from the PowerPoint slide or textbook. Okay? It will save you time. Any other questions? So that's about the exam. So we don't have class on Tuesday. Okay? If no further questions, let's briefly review what we learned last time. Okay. So we started with the correlation, and one is the scatter plot. Okay. So we described the relationship between two quantitative variables in a scatter plot. We got a bunch of data, and we displayed the data in a scatter plot. So there are several properties we discussed about the scatter plot. One is the direction. So if one variable increases and the other variable also increases, that's a positive direction. Otherwise, it's a negative. But if sometimes we cannot identify if we have a positive or negative direction. So that happens. So that's about direction. The second one is the form. So it could be linear, or it could be a curve or non-linear. Okay? So, but in this class, we only discuss linear regression or linear relationship between two quantitative variables. And the strength of the relationship, it could be very weak, it could be very strong. Okay? So that's the third one. And the fourth one is outlier. So if a data point is located far away from the majority of the data, so that will be an outlier. And also we did some exercise, and we know how to do a scatter plot in stat plot. And then we started to talk about two variables, how to name the two variables. One is the predictor variable, the other is the response variable. Okay? So in the x-axis or horizontal axis, that's your predictor variable. And in the vertical axis, that's the response variable. And correlation. So we know how to calculate the correlation. Okay? So how to quantify the strength of the relationship between the two variables? We have the expression. We did some complicated calculation here. I know you guys don't like this kind of calculation, but we already demonstrated that how to calculate the correlation coefficient in StatConf. Okay? So when you do your homework or exam, if you need to find the correlation coefficient, use the StatConf. Okay? So don't manually do it. So that's R. R is the correlation coefficient. Okay. And we did that example. And three conditions. First of all, quantitative variable conditions. Although we can find the correlation between categorical variables, but that's not our job in this class. Okay? So we focus on the quantitative variable. Linearity conditions, because we discussed we only focus on linear regression right now, linear relationship between two variables. So we need to have the linearity condition and outlier. We have to remove the outlier first. Okay? Some properties. Okay, we don't have to spend time on those properties again, so you can read it after the class. Okay, correlation table. We can display the correlation coefficients between the variables in a table like this. Because we consider the two variables symmetric, so we only have to populate half of the table. Okay? And how to define if the strength is weak or very weak or strong and so forth. So this is one instance, but as we discussed last class, it really depends on the application. Okay? So this table is not universal. Okay? It's just one instance. Okay? So this is, let's start with the new topic today. Okay? Correlation. So when we calculate our correlation, when we have our correlation coefficient, for example, is 0.99. Okay, it's very strong. Sometimes so we just say we just want to say, okay, this variable is the main factor to contribute to this variable, because it has a really strong correlation. So this variable that's the causation of this other variable. Okay? Sometimes we have this thinking logic, but in fact, as the statement said, there's no way to conclude from a high correlation alone that one variable causes the other. So this is a figure from the textbook. Okay? The horizontal axis is TVs per person. Okay? How many TVs a person has? Like in that area. So this is one variable. The other variable, the life. So that means, okay, if I have more TVs, okay, if I have one TV, probably I will live like 60 years old. But if I have 5 TVs, does that mean I will live like 100 years old? Probably. But here in this table, it has a strong correlation. But it doesn't mean this variable, the number of TVs a person has, will contribute a really long life. Okay. So that's the point we want to make. So there's no way to conclude from a high correlation alone that one variable causes the other variable. Okay. Then that brings us to another topic, another concept, lurking variable. Okay. So definition. The lurking variable is a variable other than x and y. So we are talking about two variables, right? We want to find the relationship between two variables, x and y. So there's another variable other than the x and the y that simultaneously affects both variables, accounting for the correlation between the two. Okay. Still based on the same example. This is the figure we had in the previous slide. This is a new figure. This is a doctors per person, and still the virtual axis is the life, how many average, how many years the people in that area. Still, we know that in this figure, these two variables have strong correlation. It's positive, right? This is positive. Okay. And also, if you look at this, the first figure, doctors per person, that means it's still like positive. Okay. There's a still correlation there. But can we conclude that the number of doctors will contribute long life, or number of TVs you have will contribute to the long life? Probably those two variables are not the key factor. Okay. So why do we have more TVs? So in one area compared with another area. Okay. Why this area has more TVs per person, and why one area has more doctors than per person than the other area? Probably there's another variable that affects those variables. Probably the income or economic conditions and other variables. Okay. That's why that's a lurking variable. Okay. So it will affect those variables that we see in those scatter plots. Okay. We cannot say, hey, this factor caused the long life, or this factor caused the long life. Okay. So those are not the causes. Okay. So that's the point we want to make. So when we do our analysis, when we gather our data to do some analysis, we have to be careful which data we need to find. So if we have the data about those two variables, the TVs per person and doctors per person, and also your average life expectancy. Okay. So then we do our analysis like this, and we conclude, okay, this is the number of TVs per person is the main factor. Then we will have a wrong conclusion. So you have to dig further to find out what is the real cause for our life expectancy. Okay. So that's the looking variable. Any questions? Then let's talk about the regression. Again, we are talking about linear regression. So in your StatCrunch, you will see, we will demonstrate that in the StatCrunch. You will see other options like polynomial and other logistic, those regression. But here in this class, we only focus on the linear model. Okay. So in the Tuesday class, we said there's a form called linear. So this is a linear model. So we have this bunch of data. So if we consider this as a scatter plot, we have a horizontal axis and vertical axis. Okay, the price and weight. Okay. So we want to see the relationship between the weight of books and the price of the books from Amazon. Okay. So the horizontal axis, you can consider it as the weight of a book, and the vertical axis is the book price. Okay. So if we use linear model, okay, so if we draw a line here, so that's the model we want to get. Okay, so that we can, if we plug in a weight, so we will be able to get a corresponding price. Okay, so that's our goal. And how do we get a regression model? We use this bunch of data. So that's the linear model. This is the expression for the linear regression model. So the expression is y hat is equal to b0 plus b1 times x. Okay. And here still we have two variables, y hat and x for the weight. It's not y, it's y hat. Why is y hat? Because it is an estimated value. It's not a real one. Okay? So in this scatter plot, so if you have a vertical axis, that's a real one. That's a real one. But here from this model, we did our regression, we estimated those parameters. So that's the y value we get from the model is not a real value from the data. So that's why we have a hat. So that means it's an estimated value. Okay? So that's the difference. But x, that we will have x hat because we are not estimating x value. Okay? So y hat is a predicted value. So that's the name. And B0 here, B0 is called intercept. So B0, remember the name. B0 is your intercept. And B1 is the slope. So the coefficient of x, B1, that's called slope. I believe all of you took the mathematics course, so you know what intercept means, what slope means. So this is the general expression for linear regression model. So any questions here? Any questions so far? Before we move on. So let's see one example. Okay. So the textbook did the analysis, did the regression. So they estimated the parameters. Because previously we have the intercept, we have the slope, the B0 and B1. Okay, we have to get those values. So they already did the regression. So here we have those values. Okay. So estimated price is equal to 10.35 plus 0.477 times the weight. Then we can use this regression. If we plug, we give a weight value, say 20, we will have a corresponding estimated price. Okay. So that's the linear regression. But we said, okay, we have to estimate the B0 and the B1, but how do we do that? Okay. So here is the expression to estimate, let's work on B1 first. So that's the expression. So it looks familiar and a lot of calculations. But this class, we are not doing this by hand. Okay? So B1 is equal to R. What is R here? What is the small r? What's that? Okay, this one. What is this one? Do you remember what that is called?
Correlation.
Correlation coefficient, right? So we did a lot of calculation there. Okay? So you should remember that. Okay? So that's the first value we can use. So we already did those calculations here. So we know all those values. Okay? So R we can calculate as y and as x. So those are two standard deviations. Okay? We can also do the calculation. So then using this expression we can find the B1. Okay? So this is how we calculate B1. Then we still need B0. Now we have B1, let's work on B0 now. Okay. So B0, okay, let's start from here. So this is a regression model we talked about, right? The linear model. So y hat is equal to B0 plus B1 x. If we put the B0 to the left hand side and put the y hat back to there, okay, so we will have a similar expression like this. But if we replace the y hat in x, y bar and x bar. So what is y bar and x bar? Those are the mean values, right? So if y or x has a bar there, it means it's a mean value. If it has a hat, that means it's an estimate value. Okay? Do not confuse those two things. Okay? So if you see a bar, that's mean value. If you see a hat above a y or x or a variable, that means that's an estimated value. Okay? So from the last slide, we already know how to calculate B1. Okay? We assume we already know B1. And y bar and x bar. So those are the mean values from the scatter plot. Okay? So we have the data, we have all the y values, we have all the x values. So we can do some calculation to find the mean value for y, mean value for x. Okay, so that's not hard for us. So that's why we have the y bar and we have the x bar. Then by using this expression, we will have b-derivative. Okay? So that's how we estimate the two parameters of a linear regression model, b1 and b-derivative. Okay. Any questions here? So before we go forward, let's work on one example. So let me use this data. So we use this data in last class. We did the scatter plot and we calculate the correlation coefficient. Let's use this data to build a regression model. Okay. So let's do it in the Excel first. So we have this bunch of data. So that's the first column is the number of sales people working, and the second column is the sales. So normally we treat this variable as our predictor variable because many times we want to see how many workers do we need. Okay? If I have 5 workers, what is the expected sale? If I have 15 workers, what is the expected sale amount? Okay. So this variable is our x variable, is our predictor variable, and this sales, so that's our y variable, that's our response variable. Okay. So let's do it in the how to do the regression. So we know the format of the linear regression is y hat is equal to b0 plus b1 x. So this is our regression model. Okay. So we need to estimate this b0 and estimate this b1. Okay. Let's do the b0. So what's the name of the b0? It's an intercept, right? So if we type in equal and type in intercept, okay? So the function is called intercept. And then we firstly select the y value, the value of 1. So this is our y variable, right? This is the value of 1. And then we select the value of x. Okay. Click enter, then it will do the calculation. So that's our b-derivative. Now let's work on the b1. So what's b1 called? Slope, right? So the same name, slope. The function is called slope. Still, you have to select the y values, and then x values. You got the numbers. So in this way, you have the b0, you have the b1. Okay, then you have the regression model. Okay. So that's how you do linear regression in the Excel. Any questions? Okay. But still looks like it's a little bit time consuming. Can we do it in the stack one? Let me close this one and let me do it in the stack one. So let me load this data still from file and on my computer. Let me directly drag and drop the file here. So we have the data and we click the load file. now we have all the data. So let's do the regression here. So you click this stat, and here you see there's a category called regression. Then here we only use simple linear regression. We have polynomial and multilinear and so on, but we are not covering those topics in the class. Okay, let's click this simple linear. Okay. Then we have to select the x variable, which is the number of salespeople, and the y variable is our sales. Okay. Then we just click compute. So in this table, so we have the two parameters, intercept and slope. Okay. So those are the values. So this intercept is our B0, right? This is our B0, and slope is our B1. So this 0.87, 88, something, that's our slope, B1. And if you click this arrow, you will see the linear line. Okay. And also the original data points. So this is how we do our linear regression in the stack. So your homework or your exam. So if you are given a data table, just click on that and open that table in the stack branch, and then use that simple linear function to have your regression model. And there are other information, R-square and estimated error, standard deviation, and so on and so forth. We will talk about those concepts later. Any questions? So let's make sure let's use the sequence in your step to save time. Okay, so that is the linear regression model. So let's talk about a new concept, residual. Okay. What is a residual? That's the difference between the actual data value and the corresponding value predicted by the regression model. So that's like we saw in the cycle. So we have scatter plot, and we have a lot of data. And based on the regression, we have a linear line. We know that those original data points are not located exactly on the line. There are some differences. So residual, that's the difference between the predicted value and the actual data. Okay. So it's denoted as E, small e. So E is equal to y minus y hat. Okay. So that's where we have both y. Okay. Y is your actual data. Y hat is your estimated data. Okay. So this is x, and this is your y. So we have a lot of data points. We use those data points to do a regression. Then we have this line. Okay. But the problem is there are some differences between the estimated value and the actual data. For example, here, okay, we have x1 here. Okay. And this point, this is our x1, y1. Okay? This is our actual data, right? This is our actual data. But if we put this value into our regression model, what is the y? So y is here. Let me see if I have. So let me use it. So this is our estimated value, right? Because it's from the regression model. This is y1 hat, and this is your real y1. Okay, so there's a difference. This difference difference is your residual. That's the residual. Y minus y hat. So let's make sure it's y minus y hat is not y hat minus y. So that's why your residual could be positive or negative. Okay? So that's the difference. So that's the residual. So if we look at other data points, okay, for this one, there's a corresponding x value. Okay, this is the actual data, and the corresponding real y value is here. So this is the y value. And if we use the regression model, the estimated y is around here. So it's different. So this difference, those differences are the residuals. Okay? So any questions on this concept? Okay. So that's the residual. And standard deviation. So we can calculate the standard deviation for the residual. So using this formula. Okay. So the summation of the residual square over n minus here. Remember, be careful. This is n minus 2 is not n minus 1. Okay, and take the square root. Okay? This is the residual. This is the standard deviation of residuals. Then let's talk about how, so if we are given a bunch of data, so if we are given this bunch of data, so let me do it here again. So we have several options. Right? So I can do a linear line like this, or I can do a linear line like this. So which one do we use? There are too many options. Which one should we use? Which is the best regression model? Okay. So when we do our regression, we have to calculate the least square. So if you read the textbook, that's called least square. So when how do we measure if the regression model is good or bad? Okay. We use this R square, the squared correlation. So that gives the fraction of the data variation accounted for by the model. Okay. So we know there's if we are given a bunch of data here, so the y value, there are some variations. So let me erase this one. So we have several data points here, there, here. So for example, we have five data points, and each data point has a unique y value. Okay. So that means there are some variation from this 5 data points. So this is the y1, y2, y3, y4, y5. Okay. So if we calculate the mean of y, for example, the mean is here. Okay. So this is y bar. Okay. So the mean value of those y is here. We know there are some difference, there are some variation. And so on and so forth. So that's the difference between y1 and y bar. This is the difference between y2 and y bar. So that's the that's a variance from the original data. But what does this mean? So now we have the regression model. Okay? So if we take a value here, and here, and here, let's do it here. So we know the difference between the actual y value with and its mean value is here. Right? So that's the difference between the actual y value and its mean. And here is our estimated. This is the y4 hat. Okay? It's on this line. And this y4 hat has some difference with this y bar, the mean value. Okay? So this is the difference between y hat and y bar. So if this difference is small or large, what if this and here we also have the difference here between the actual value and y4, the actual y4. So if the difference is really, if this difference is really small, let's say 0. So if a line has all the estimated y value has no difference with the original actual y value, that means all those data points are exactly on the regression model, right? Exactly on the line. So that means it's a perfect fit. But if in real case, that's nearly impossible. Okay? But if we have a really small difference between the estimated value and actual y value, that means we have a good estimation model. Okay? So that's talk about how closely the actual y value with the estimated value. So the R square, the range of R square is between 0 and 1. Okay? So if we have a really large R square, that means that's a good fit. Okay? That's a good model. So if we have a 0, say 0, R square is 0, that means there's no correlation between the actual data and the estimated data. That means we have a really bad estimation. We have a really bad regression model. Okay? So R square. So if you have a big or large R square value, that means we have a good regression model. Okay? So that we don't have to learn how to calculate the R square, but we should know that R square, if we have a large value, that means we have a good regression model. Okay? That's all. Any questions here? So we are done with this chapter. Okay, some key points. So how to describe a scatter plot? Direction, form, strength, and if there's any outlier or not. So correlation. So how to find the correlation coefficient? Okay. And conditions and the properties, list of properties, and how to do the linear regression in the stack count and also the Excel. And R square. What's the definition of R square? So those are the concepts we need to know about this chapter. Okay. So this is the chapter 4. So any question before we do chapter 5? So in chapter 5, let's talk about some randomness and probability. Okay. So we will learn some basic concepts about the randomness and the probability, and we will learn different types of probability and also some rules. Okay. So we have several topics to discuss in this chapter. So let's talk about the randomness first. What is random phenomenon? So a phenomenon is called random if we know what outcome could happen, but we are not sure which particular values will happen in any given trial. So some events is called random. Okay? We know what are the values we can expect, but we just don't know what values we will get particularly. So how many of you buy lottery? No one? Okay. Powerball. But you heard of Powerball, right? So that has a lot of money in there. So you know what numbers are there, but probably you do not know what number you will get next time. So that's a random. Okay? The outcome, that phenomenon is random. We know the outcome, but particularly we don't know what exact value we will get. So we cannot predict individual outcomes, but we can hope to understand the characteristics of the long-run behavior. So that's a coin, right? That's a coin. So if you toss a coin, you know what are the possible outcomes. So you can either get a tail or a head, right? Only two possible outcomes. But if you toss a coin, do you know which side you will get? Probably no. But we know it should be either head or tail. So that's a random phenomenon. Any other random phenomena you can think about? Okay? So we have a lot of random phenomena in our daily life. What other events or other phenomena you can think about the random phenomenon? What is random in your life? So you guys are 100% sure of all the things in your life? That's a good thing, right? What about, how many of you take shuttle between the two campuses? Okay. So what about the arrival time of a shuttle? Is that set random or is deterministic? Random. Okay. Probably every day it arrives at a different time, so you don't know when it will arrive. But you have the app, you can track that. But the actual arrival time is random. Okay. Anything else?
Maybe the weather.
The weather.
Maybe.
What's your
Like a work schedule is kind of random.
work schedule?
I
So.
mean, you would know like what day, but you wouldn't know like what time.
Okay. So for me, that schedule is fixed. Okay, we have that class schedule. But let's talk about the work first. Then let's talk about the weather. So if so can you give more information about the
Well, I
work?
work at public and we get our schedule every week.
Okay.
So it's like, well, not the days, because I have like set days, but like the times would be different.
Okay.
Or just like random, however you want to like.
That's possible, right? That could be random. Okay. This week you work so you work on Monday, Wednesday, probably next week you will work on Tuesday and Thursday. Okay. So your boss will be the guy to determine that your work schedule. And weather. So do we know what's gonna be the temperature 3 p.m. today? But we have some possible outcomes, right? From say 30 degrees to 120 degrees. At least one of them, right? But we don't know which one. Okay? So we have a lot of random phenomena in our life. Okay? So that's the theme we are going to discuss today. Okay? we cannot predict the individual value, but we know the long run behavior. For example, tossing the coin. The next one, I don't know I'm getting a head or tail, but we know that in the long run, half of the chance I will get a tail and half of the chance I will get the other side. Okay? So we need to talk about some terminology. Trial. A random phenomenon consists of trials. What is a trial? A single attempt or realization of a random phenomenon. So if I toss a coin, that's one trial, right? This is one trial. And each trial has an outcome. What is outcome? Outcome is a value measure observed or reported from an individual trial. So if this trial, if I toss a coin, that's a trial, and I get a head. Okay? I get a head, and that's the outcome of that trial. Okay? That's a value, head, that's from that trial, that's an outcome. Okay? So trial and outcome. So the outcome or this outcome doesn't have to be like quantitative. The temperature, the weather, the temperature, it could be quantitative. But for this one, tossing a coin, head or tail. It doesn't have to be quantitative or numeric. So those two concepts, trial and outcome. Event. Outcomes combine to make events. So event is a collection of outcomes. Okay. One example. So if I toss a coin twice, I'm interested in can I get at least one head from the two tosses? That's the event. I'm interested in the event that I get at least one tail or head from tossing the coin twice. So that's the event. So that event has a collection of outcomes. Okay? At least one head. What does that mean? That means I can. So I toss the coin twice. One possible outcome is I get the first from the first toss I get a head. The second one I also get a head. Okay? That's one possible option. The second option, the first time I get a head, the second time I get a tail. Okay? It's also at least one head. Or the third one. The first time I get a tail, the second time I get a head. Okay? So three possible outcomes. So that defines that event. Okay? So that event is getting at least one head from tossing the coin twice. So that's the event. Sample space. So now we started to talk about sample space. This is the first time we discuss the sample. So we will use this terminology very often after in the following chapter. Sample space. The sample space is the collection of all possible outcome values. Okay? So if you just consider tossing the coin once, what are the possible outcomes? Head and tail. Okay? Only two possible outcomes. Another example, if you roll a fair die, it has how many? Six sides, right? So there are 6 possible outcomes. So that defines the sample space. So remember, sample space contains all possible outcome values. and sample space is denoted as S. Okay? And the event, so if you define an event, it's denoted as E. Okay? E and F. Okay? So that's a symbol we use to define the sample space and event. Any questions so far? Okay. So we have to be clear about those concepts. So let's see one example. And this example is also from the textbook. Okay. We want to have some credit card application. So if you apply credit card, so they will check your credit. Okay. So then they will determine if you are qualified or not qualified. Okay. So that's the scenario we are talking about. Okay. So we are given different calls. So they consider, okay, they receive several phone calls and they get the credit score for those applicants, and they determine if they are qualified or not. Okay. So if we look at each call, okay, so each call is it's a trial, right? That's a trial. So there are two possible outcomes. It's either qualified or not qualified. So two possible outcomes. So that's why the sample space, either qualified or not qualified. We only have two outcomes in our sample space. Okay? So that's our sample space. And we look at each call. So each call is our is one trial. But if we look at two calls together, okay, so what are the possible outcomes? Okay. Both applicants are qualified. That's one possible option. And the other option, another option. The first one qualifies, the second one not. Or the first one not, the second one qualified, or neither of them are qualified. Four possible outcomes. And sample space, it contains all those possible outcomes. So if you miss one of them, that's not called sample space. So if you define the sample space, it has to have all the possible outcomes. Another reference, at least one qualified caller from two phone calls. So those are our possible outcomes. Both qualified, the first one qualified and the second qualified. Three possible outcomes, and our sample space has those three outcomes. So that's one example. So that's our event. So any questions before we move on? So those definitions: trial outcome, event, sample space. So let's talk about the probability. Okay. The probability of an event is the long run relative frequency. Remember, it's a long run relative frequency. So that's the probability. The simplest example, tossing the coin. What's the probability of getting a head? What's the probability? 50%, right? And similarly, for the getting a tail, 50%. So that's a long run relative frequency. So the keyword is the long run. What about the short run? So let me do 3 experiments, okay? The first one, a tail. The second one, a head. Third one, a head. Let me do one more. A tail. Okay, that's called coincidence. Okay, so half. But the key point is that's a long run probability. Okay? So it's possible if you look at the short one. if you toss a coin for 10 times, it's likely that you get 6 tails and 4 heads. Okay? But that's not the probability, because we know it's a high okay? So that's why we have to emphasize that's a long run relative frequency. That's the first terminology, the probability. Then the independence. Okay? So we briefly talked about this term in the last chapter. So when we talk about two variables, so if the change of the value in one variable does not affect the value of the other variable, that means those two variables are independent. But here, we use a similar concept, but we apply that into different trials. So the outcome of one trial does not influence or change the outcome of another. So if I toss a coin twice, so is the outcome of my first trial affecting the outcome of the second trial? No, they are independent, right? So it doesn't matter if I get a tail or head in the first trial, still that for the second trial, I get half chance of tail and half chance of head. Okay? So that's why we call it independent. Okay? It's independent between the trials. Let's see some examples. Okay? We take some the snapshots from the math lab, so you will have similar questions in your homework. Okay? So the last digit of the security number of students in the class. So which option is correct?
A.
A. Independent because outcome of one trial does not influence or change the outcome of another. So does my social security number affect yours? No, right? So independent. Okay? So that's one example. The second example. Okay? So lottery. Okay, you can choose which number you may consider a common form where you choose 5 numbers. Okay? Then they suggested 2 strategies to improve your chance of winning. So the first one is, so we're randomly choosing from among the numbers that have not come up in the last 3 lottery draws, improve your chance of winning. Is that going to work? Which is correct?
B.
B? No, not improving. Because each number drawn is equally likely and independent of others. Okay. So that's independent. Okay. You cannot use the historical data to predict what's going to happen in the next trial. Because they're independent, but still many people just look at the historical data to try to find some tendency or some trend in order to predict what's going to happen. But that's not possible. So B is our option. So, but we have another suggestion. We are generating random numbers using a computer or calculator to improve your chance of winning. Let's do some simulation. Okay? To see which number or which 5 numbers have more chances. Can we do that? Is that going to work or no?
A.
A? because each number drawn is equally likely and independent. Okay? Still, they're independent. No matter how many times you try, even if you try 1,000,000 times, you get some results. If the next time is independent from what you did. Okay? So that's the independence. Okay? Then let's talk about some properties about the probability. Okay? So the law of large numbers. Probably you learned that from other math classes. So that's a long run relative frequency of repeated independent events eventually produce the true relative frequency as the number of trials and errors. So that's the law of large number. So still, let's use the message. Let's use the tossing the coin example. We know the chance of getting head and tail is half-half, right? But if we try 10 times, probably we get 3 heads and 7 tails, which is not equal to half-half. What about 20? Maybe 11 tails, 9 heads, still not half-half. But if we try a large number, say let's do 1,000,000 times. Let's toss the coin for 1,000,000 times. Okay? Then you record the results. Probably if you compare those two results, you will get nearly half. Okay? So if you increase the number of trials into infinite, you will get the exact the number as half-half. So that's the law of large numbers. Remember, it's independent and long-run relative frequency. That's the law of large numbers. Then we will talk about some probability. There are different types of probabilities. Okay? The first one is called empirical probability. The definition is that when the probability comes from the long-run relative frequency of the event's occurrence, it's called empirical probability. So here is the expression. So the probability of event A, so we have an event. Okay? The probability of event A is equal to the number of times event A occurs, divided by the total number of observed occurrences. Okay? So that's the probability you get from actual experiments or actual trials. Okay? So tossing the coin, if you toss the coin 100 times, you get 49 heads. Okay? Then the probability of getting a head is equal to 49 over 100. Okay? 49%. So it should be coming from the actual experiment. Okay? So that's the empirical probability. Or if you are testing a new drug, you have the test or you do experiment on animals. What's the probability of getting a negative reaction or effect? So that probability is from your actual experiment. So that's the empirical probability. The second type. Okay? Model-based or theoretical probability. So when the probability comes from a mathematical model, okay, it is called theoretical probability. The probability of event A is equal to the number of outcomes in A and total number of outcomes. So we use this theoretical probability a lot in the following chapters. Okay? So we will talk about different distributions, and based on that we calculate the probabilities. Okay? So it's based on the number of outcomes in an event, and the total number of possible outcomes. It's not directly from the experiment. So that's a model-based probability. So this is the second type. So we have a third type, which is called, let me skip the other one. This is one example, okay? Rolling a fair die. We have 6 possible outcomes, and the event of getting the 6, it has only one outcome, right? So it's called, it is 1/6. That's not from the experiment. The third one is personal probability. So when the probability is subjective and presents one person's personal degree of belief, is called personal probability. For example, what's the probability that you will get an A in this class? Okay. So if I say, okay, 90% or 80% or 100%, so that's the personal probability. Then if I ask you, what's the probability you think today it will rain? You say, okay, probably 40%. Then that's your personal probability. Because that describes a personal belief, degree of belief. So that's the personal probability. So 3 types of probabilities: empirical, model-based or theoretical, and the personal probability. Okay. So any questions? So I think we will stop here. So next week we will talk about some probability rules. Okay. So we have, I think we have a homework due today, right? So make sure you work on that. So if you haven't signed up here, please come here to sign up. Some of them have multiple, just like the homework question.
Oh, yeah, I can hear it.
So are you gonna upload the chapter on 4?
Yes. So chapter 4, I think is already there. This is
Chapter
yeah. Yeah.
File.
Yeah.
Upload file.
Yeah, I will upload file.
Alright, thank you.
I had emailed you because my Pearson account wasn't working, but I'm gonna contact them. It's still like loading slow, like the contact page, you get the number and stuff, but I'm gonna try on like another computer, or I might just get it from like Google
Yeah,
or something.
sometimes it has some problem, but I haven't heard from other students about this issue. Probably that you may have to change a browser or
Okay, cause I'm
Yeah.
using Chrome, so do I need to use like Internet Explorer?
I've been using Chrome, so it has no.
I don't know. I'm gonna
Yeah,
think about
probably
it.
you can try another browser to see
Okay.
if it works or not.
Okay,
Yeah, it happens sometimes.
alright. Okay, have a good one.
You too.